For the set part of our Unit 4 Lesson 2 practice, this looks a little bit like the lesson from class. So let's read the top part together. Jackson likes to be organized, so he made the following chart. He has decided to keep track of the miles he runs. That seems important, so I'm going to underline or highlight it rather. And the time he spends running. So those are two different things, right? Miles versus time. He attends PE class on Mondays, Wednesdays, and Fridays, but he goes to school every day. So in question 8, we are first asked to fill in the units column of the chart. So we're told the symbol M is going to represent the number of miles ran in PE class on Mondays. So the units, what's being counted or measured, is the distance run in miles. So the thing that's being measured is distance, but the units in which we're measuring distance are miles. So for W, number of miles ran in PE class on Wednesdays. And for F, the number of miles ran in PE class on Fridays. So far, those first three symbols or letters or variables represent miles or distance in miles. But then we have the letter S, the variable S, and that represents the number of miles from Jackson's house to the school. So we're still measuring in miles. H represents the time in hours to travel to school. So now the variable that we're measuring is time and the units are hours. And then lastly, uppercase T represents the total time in minutes spent in PE class. So both H and T are variables that are representing time in one way or another, but uppercase T is measured in minutes. All right, so for the next several questions, it looks like through 14, we are asked to use the table from question 8 to make meaning of the expressions below and write what the expression means. So another way of thinking about this is we're defining the expression in context. So if I add M, W, and F, I'm adding the number of miles ran in PE class on Monday with the number of miles ran on Wednesday in the PE class, and we're adding to that the number of miles ran on Friday. So there's a lot of ways that we could express this, but we might think of this as the total number of miles that Jackson ran in his PE class in 1 week. So that's how I'm going to answer this question. I'm going to say this represents the total. So the word total implies that we added number, that's number not hashtag, of miles Jackson runs in PE class in 1 week. All right, so question 10, underneath that, I notice that that is the same expression, except that it's being multiplied by 4. So everything right here is still the total of numbers run in a week, but now he's doing that 4 times. And if you think about it, we have about 4 weeks in a month, not exactly. So you could really, like, if you want to be very literal here, we could say this is the total number of miles that Jackson runs in PE class in 4 weeks. That would be very correct. I did check the answer key to this one because I was curious. And in our OUR solutions, that is just on the teacher page, you guys don't have access to it, it did say that this is meant to be the total number of miles ran in a month. I think they're both correct. So I'm going to say the total number of miles Jackson runs in PE class in, I'm going to say 1 month, but I think it would be totally acceptable and probably more correct to say 4 weeks. since we know a month is not exactly 4 weeks. All right, for number 11, now we have S divided by H. So if I look up at my table, S is the number of miles from Jackson's house to the school, divided by time in hours. So this is going to, we could think of this as a rate when I'm dividing one variable by another. So if we're being literal here, we could think about this as S representing really the distance from Jackson's home to school. So we could say this is the distance from Jackson's, I'm just going to write J's, home to school, divided by, well, the time it takes him in hours. So divided by the time it takes Jackson to get to school. But what this really is if I divide the distance from Jackson's house to school by the amount of time and hours it takes him to get there, that really gives us like the average rate at which he is traveling. So back, I actually just want to scroll up for a second. In the ready portion of the Ready, Set, Go, we looked at this equation, and again, you might see this in a science class, that distance equals rate times time. And so if you divide both sides of this equation by time, I know that's not what we were asked to do in number 4, you would get that a rate is the rate at which you travel, we call that velocity, is distance divided by time. So all that to say, we could think of this as the average rate, and I could think of that as velocity or speed if I'm just considering positive values. That it takes Jackson to travel to school. And we need to include units here. So this is measured in miles per hour because, again, S is measured in miles, H in hours. So I'm dividing miles by hours. So I could say in miles per hour, you could write MPH. You could say miles per hour, or you could say miles, like the fraction bar. In this context, we would read as per, so miles per hour. Okay, then lastly, if I look at number 12, F minus W. So F is the number of miles ran in PE class on Friday. W, the number of miles ran on Wednesday. So this is really the difference between those values. So we would read this as like the difference in miles that Jackson ran, we might say between Wednesday and Friday. So if that expression is positive, like if I were to actually plug in numbers and I got a positive, that would mean that Jackson ran more miles on Friday than Wednesday, and vice versa. If that expression gave us a negative value, that would mean that he ran more on Wednesday than Friday. All right, for 13 and 14, we are asked to create an expression based on the table from question 8 for the quantity described. So in 13, it says the amount of time spent traveling per week. Now, the word traveling here, you could argue that's a little bit vague, but I'm going to say that when Jackson is running in his PE class, I'm not considering that travel. So where I see the word travel more literally, although I suppose you could make a case for running, I mean, it is travel, I see that he is traveling to school. And so H represents the time in hours for him to travel to school. And we're trying to figure out the amount spent traveling per week. Well, and like we're just in this context only considering his time for school. So we got to be careful here. If H is the time it takes him to travel to school, I think we should assume that he has to come home from school. So if I were to write, for example, the expression 2H, that would represent his like daily travel to and from school, because just H is his travel to school, but then he has to travel H, miles back. So then if he's traveling in the whole week, now remember, Jackson attends school every day, so that is 5 times, right? So that would be his 2H times 5, and that would be the same as 10H. So the amount of time spent traveling per week would be the expression 10H. All right, and then in number 14, miles round trip from Jackson's house to school and back. So we're not talking about time, but we're talking about distance from his house to school and back. So if S represents the number of miles from his house to school, well, if he then has to return that same distance, well, that would just be 2S, right? Just like how up here, this was 2H. So miles round trip from Jackson's house to school and back would be 2S. If you were to say S plus S, that is also correct. But remember, you can add 1S and 1S to get 2S. So those expressions are the same. All right, that concludes the set portion of our practice.